For this video, we're going to be looking at solving an application problem with these three variable linear systems. To solve this, we're going to solve it just like what we did with our systems with two variables, where we're going to identify what the variables are, look at totals, and create equations, and then solve from there. So this problem says an amphitheater charges $70 for each seat in section A, $55 for each seat in section B, and $30 for each seat in section C. There are 3 times as many seats in section B as in section A. The revenue from selling all 23,000 seats is $870,000. How many seats are in each section? So my first step here is I want to see where am I going? What am I trying to find? Well, I see in that last sentence, I want to see how many seats are in each section. So that's going to be my variables. So I'm going to allow X to be section A, Y to be section B, and Z to be section C. And so now I'm going to go through sentence by sentence and see what equations I can make and look for some totals. Well, I see at the second to last sentence, I see that the revenue from selling 23,000 seats, so I have a total there's 23,000 seats, and I see from selling those, they got 870,000. So I have two totals from there. I know one of these is going to equal to 23,000, and another is going to equal to 870,000. Well, if X, Y, and Z stand for how many seats are in each section, and there's 23,000 total seats, this first equation is just going to be X plus Y plus Z. And selling all these gets you a revenue of 870,000. Well, how much does each seat cost to get that? Well, I've seen this first sentence that it's $75 for each seat in section A. So I have 75X. $55 for each seat in section B. That's going to be 55Y. And then $30 for each in section C. So it's going to be 30Z. That's my second equation. And then I see in the second sentence it says there are 3 times as many seats in section B as in section A. So there's 3 times more in section B than there are in section A. So that means that Y is going to equal to 3 times X. Because Y is section B, X is section A. And so those are the 3 equations that I get. Now I need to go ahead and actually solve this system. So this one looks a little different from the problems that we did before, where all 3 equations looked like these first 2. Here, I actually have my third equation is already in only 2 variables. Z isn't in that one. So to solve this one, what I can do is I can go ahead and substitute in my value of Y into one of these equations, or into both, so that these 2 equations, 1 and 2, can be in 2 variables. So I'm going to go ahead and substitute it into both. So I'm going to first substitute it into 1. And so when I substitute it into 1, I get X plus 3X plus Z is equal to 23,000. And simplifying that out, I get 4X plus Z is equal to 23,000. And then substituting into the second equation, I have 75X plus 55 times 3X plus 30Z is equal to 870,000. 255 times 3, I get 165. And then when I add 75 plus 165, I get 240x plus 30z is equal to 870,000. So now I have a new system that's in 2 variables. And so now I can go ahead and solve this new system for x and z. So I have 4x plus z is equal to 23,000. 240x plus 30z is equal to 870,000. Here, I'm going to go ahead and solve this by elimination, and I'm going to go ahead and eliminate my z, just since that will work with smaller numbers. So to do that, I need to multiply this top equation by negative 30. And when I do that, I get negative 120x minus 30z is equal to negative 690,000. And so my z's cancel, and I get 120x is equal to 180,000. Divide both sides by 120, and I get that x is equal to 1,500. And so from here, I can go ahead and plug this back into either one of these equations to find my value of z. I'm going to go ahead and plug it into the first equation, just since that deals with smaller numbers. And so when I do that, I get 4 times 1,500 plus z is equal to 23,000. Well, 4 times 1,500, I get 6,000 plus z is equal to 23,000. And when I subtract 6,000 from both sides, I get that z is equal to 17,000. So I have my x and I have my y. Now I need to figure out what x and z, I need to figure out what y is. And so I'm going to go ahead and just use equation 3, since that one's simplest. It's already solved for y, and figure out what y is equal to. So I have y is equal to 3x. So that means that y is equal to 3 times 1,500. So y is equal to 4,500. So that means, writing that all out, there are, section A has, which is x, has 1,500 seats. Section B has 4,500 seats. And section C, which is Z, has 17,000 seats.